Hi student teachers, welcome to your first year semester 2 for maths modules with Miss Vega. What is our learning outcomes? The first one will be to establish understanding with Luneta chapters regarding CAPS content areas within learning unit 1 for semester 2. What's our second? Our second would be evaluating examples of formative assessments with answers for learning unit 1 semester 2 regarding CAPS content area. The textbook that we need for this semester would be Luneta, Killen, and Departments of Education CAPS. Well, let's get straight to looking at second semester. What would possibly, be tested on for the concepts area of numbers, operation, and relationship would be chapter 15, developing early number ideas and strategies. Chapter 16, introducing place value. 17 would be developing additive thinking in grade 1 to 6. 18 would be developing multiplicative thinking in early years. Patterns, fraction, and algebra will be chapter 14, patterns and structure. Chapter 19, introducing fractions and decimal fractions. This would be covered in learning unit 2. Measurements would definitely be chapter 20, developing measurement concepts and strategies. Data handling would be chapter 22, early chance and data. Let's get to the examples for formative assessments for these two chapters, actually content areas in particular. The question says, read chapter 14 of Luneta, of course, and answer the following questions. The first one would be, let's move on. The first one would be explain the link between laying a good foundation of pattern and structure and successful algebraic thinking. Now, pattern and structure in mathematics describe the graphic figures and its traits as a trait on a sequence. Similarly, as algebraic thinking, patterns and structures also deal with seeking a single numeric solution to an arithmetic problem, ultimately expanding chances to building more patterns and generalizing trends in the sequence and relationships within the sequence. Having the ability to notice pattern and trends in the sequence of arithmetic figures, and it creates foundational understanding on geometric thinking works, developing its computational skills for the learner. So to unpack that, it just generally means that patterns and structures have one thing in similar with algebraic thinking. Algebraic thinking and patterns have this three things. The first thing is the pattern. What are we looking at? Is it numbers, or is it a graph, or a figure, a shape? And within those changes, what's the trend? What usually changes? And that's what we call the rule. So for an example, if you go back to your high school or primary school knowledge, you would find out that a graph increases by a number or a difference of 2 or whatever. That's the rule, that's the trend also. So algebraic thinking is really noticing the trends, the patterns and trends in the sequence, in the figures. So it develops algebraic thinking because it has the same type of rules. And so also patterns and structure in maths develops computational skills for the learner. What does computation skills? It generally counting. It's mental ability to count, whether it's addition, subtraction. It's learning how to work through maths. Okay. For the second question, explain what is repeating pattern and give an example. Repeating pattern, that is predictable sequence of arithmetic figure and numeric. For example, a pattern is red, orange, green, and blue. Red, orange circles. What is the next three expected color circles? So it's red, it's orange, it's green, it's blue. So these four are super different. And then it starts all over again, red, orange, what's probably next? Green and blue. So repeating pattern cultivates multiplicative thinking and proportional reason and ratio. To find out more, you will find it in chapter 14. Okay, third one is explain a growing pattern and give an example. Growing pattern has a change in quantity of arithmetic figure or a numeric, in the sequence. This change may be increasing or decreasing in value. For an example, 1, 3, 5, 7, 9, 11, and 13. We can all see the trend that one of the things is that there's a difference between them, which is 2, and most of the time they are odd numbers. So the sequence shows a clear increase in pattern by the additional 2 of the every number. This type of sequence can be easily assessed and as it continues by finding the missing term and predicting future term judging from the sequence trend. This type of pattern encourages functional thinking, and functional thinking trains the child's mind to predict and work with constant change on a mathematic problem. This is all available in chapter 14 for Luneta. Okay, next question. Clarify the difference between procedural and conceptual understanding. Conceptual understanding is a learner's interpretation and use of interconnected ideas from prior knowledge and existing new information. It helps the learner to find solution on presented problems, whereas procedural understanding is the learner's ability to memorize, process, to serve mathematical concepts without interpretation or prior knowledge. A simple example for these two, conceptual would be maybe the understanding of shapes, may I say, like you know the shapes, there's 2D shapes. So you may tell the child, yo, look outside the brick, the wall has rectangular shape. If you look at it and touch it as a flat wall, you say it's a 2D shape with your sides. Just like by looking at it, you would say it's a 2D shape. But take the brick out, it's 3D because you can touch all sides, you can look all dimensions. So it's conceptual. It's what a child interprets it with their own prior knowledge, like looking at a honeybee or tiling or just the things around the child would predict that mathematical concepts with their own prior knowledge, mixing the new information. But conceptual would be things like formulas, x plus y is equal to whatever formula. Oh yes, x plus y is equal to r, you know, those radius, the circle thing. So those are concepts that cannot change. You have to use those formulas to get through a mathematical concept. Okay, define functional thinking and explain relevance it has in teaching underlying concepts instead of focusing on computational experts. Okay, functional thinking emphasizes on operational relationships between mathematics concepts. It teaches a learner to understand the underlying procedure to solve a mathematical problem. Using found relationships between two or more numeric, for an example, telling a learner that 3 plus x is equal to 4, find x. You teach them to cross the 3 over the equal sign and change it to a visible positive sign. Change the visible positive sign into a negative since it's crossing over, making it x is equal to 4 minus 3, letting the learner know your answer is complete since it's positive, as the question asks to find a positive x. Such is training the learner's computational skills in finding a growing pattern of solving mathematical problems of using functional thinking. Okay, draw a fun A4 poster for your class to explain the equal sign to the equal to sign. So here's my example. Just look at that. That is, I used simple PowerPoints, nothing special. A little icons from the internet, a little fun facts with the bubble using smart arts in PowerPoint. This was already available to PowerPoint. I just needed to add values. And fun facts. Let's just get a closer look at it. As you can see, the equal sign, here's to start the title, add a little like plus signs, division, anything that might interact. The equal sign shows the relation between numeric and arithmetic figures on both of the sign. For an example, x plus 5 is equal to 6. Putting a little pictures for kids, because kids like to learn with color and imagery just to excite them, and having an image right at the bottom and putting a bubble, it teaches that we're teaching something. The equal sign, let's get that a bit more closer because it seems too far. There we go. The equal sign is a mathematic symbol in which it shows the same measure on either side of the equal sign. So 3 plus 2 can be equal to 4 minus 12. This is another example in functions. That's something that kids are still going to learn. The circle has its own formula, which can be just equal to x, just to find the outputs and the inputs with the rules. Just to come a little more closer here, you can see fun facts right at the bottom. What is quadratic formula? It encourages functional thinking of the learner, focuses on operational relationships, and the mathematical concept teaches a learner to understand, underline the process, solve mathematical problem using the relationships between the two numerics. And that's just the formula of the graphs and just how to use functional graphs. That's just the basic idea of maths. Put in colorful pictures, put in graphs, just make it more appealing to a child. Put in fun facts that are a bit above their grades just to keep interest for them. But yeah, that's just example the charts. For formative, another one. This is a second example on how to do a formative assessment. Let's read together. As Luneta textbook has guided, create one of your own engaging activities for the learners to complete that supports the learning of measurements, and use your CAPS documents to aid you in pitching the lesson that you find an appropriate level for grade 4 learners. The activity should be worth 10 marks, objective listed, cover multiple cognitive levels, and you can select any two of the following topics for your activity, whether it's length, mass, or capacity. Okay, we are going to cover measurements, length. Looking at CAPS, first thing that you need to know about CAPS, it gives you an underline of what the progression it is going to, the teacher is expecting to teach from grade 4 to 5 and 4 to 6, and the increase of complexity. This part is very important because it kind of gives you an overview of what's going to happen over the 3 years as the child progresses. Looking at grade 4, that's what we're focusing on, and we chose length. We need to have practical measuring for 2D shapes and 3D shape by estimating, measuring, recording, comparing, and ordering, and using the measuring instruments such as rulers, meter sticks, tape measures, and etc. The units that we need to look at a lot as at testing the child for the worksheets would be millimeters, centimeters, meters, kilometers, any one of the 4. But at the end of the day, they need to know the relevance between them as, meters. Of course, calculations and problem solving involving length, that's also important. We're only focusing on grade 4, guys. So we solve problems in constants of length, conversations, including converting millimeters to centimeters, centimeters to meters, meters to kilometers, and conversations limited to your whole number and common functions. Now, for a 10-mark worksheet, you don't have to cover everything. You can basically cover half of this, and then the next worksheet is half of this. But because we work with blooms, we have to have a little of everything to have a sense of balance and good clarity for the child on their worksheet. Now this is a worksheet that I put together. This is assessment for learning. I'll put a tag above the difference between assessment for learning and assessment of learning. There's different things, but just to give you a bit of a recap, assessment for learning is formative. It's one of those assessments that you do during class. It's not necessarily for recording. It's not really for for passing the grade assessment. It's really for you to teach the child at the moment what they need to know. Okay, let's look at the worksheets. Grade 4 measurements length. The first thing is state what is length. Explain the difference between centimeter and meter. Exercise 2. This is a reminder. I feel it's very important. Since they're grade 4, they're very young. They're still learning contents. You have to add clues. You have to have some form of information. How many centimeters is there in 2 meters? Now that's a problem solving. How many meters in 4 centimeters? again, the reminder, 1 kilometer is equal to 1,000 meter. How many meters are there in 4 kilometers? Exercise 3. Write the answer the question with the aid of the picture. As you can see, it's a crayon, something they would have in their own reach, which is a ruler and a crayon. It's grade 4, keep that in mind. And how many centimeters is the crayon? Something that's relevant to them because they've just like came out of foundation. They know what's a crayon. And draw your own 4 centimeter crayon with a ruler, just as the example shown in the above aid, 2 marks. Okay, let's first, before we go to Bloom's, let's see if according to CAPS we have done what we have asked to do. Okay, CAPS said measure 2D shapes or 3D, so technically they are here. For length, estimating, measuring, recording, comparing, using rulers, or here. While we have really asked the child its most basic understanding of the concepts. And 1 meter, like we've reminded the child what is the content practically. Well, looking at Bloom's first question, which is the bottom. Remembering is adjectives such as define, duplicate, memorize, repeat, state. So the first thing that we did, do you remember what is length? That's why we're really asking what is a length, first of all. Second application, oh no, you actually jumped to analyzing what's the difference between centimeter and meters. Okay, so we did apply multiple cognitive levels as the assessment asked us to do. Second exercise, how many centimeters are there in 2 meters? That is what CAPS calls problem solving. According to CAPS, we are problem solving using centimeters and meters. Right at the bottom of CAPS, the previous picture of CAPS, it says problem solving. How many? So according to Bloom's, if you ask this kind of question, it applies in really finding out if you can apply this knowledge. It's estimating. It's really solving. That's the one. It's solving, because now you're demonstrating, the child is demonstrating if they know how to convert these length conversions. So in Bloom's, this is applying. So is this one, because it's really the same here. For number 3, the child is, well, really answering a basic question, which is analyzing. Can you see, like, can you compare? It's asking the child, compare the ruler with the drawing of the crayon and answer the question, how many centimeters is there? So it's within the realm of analyze. Now, this is the final part, draw your own. Drawing is under creating, because now you're asking the child to produce their own original work. So this whole worksheet, the assessment for learning, has covered literally every part of Bloom's, except for this one. Okay, the memorandum. It's important for a teacher to have a memorandum. First of all, you cannot have an assessment without a memorandum. It's like breaking the law. So as you can see, length is a distance between 2 points. explain the difference between centimeter and meter. A meter is equal to 100 centimeters, while a centimeter is equal to 0.01 meter, 3 marks. So you have to have text, like basic, you need to do that. How many centimeters is 2 meters? 2 meters is 200 centimeters. Ooh, no. Yes, it's 2000. Excuse me. How many meters? Meters and 2 and 4 centimeters. Well, you get the jiffy here. And yeah, that's the memorandum. Okay, the next topic would be capacity. Let's look at what CAPS tells us to do for capacity. It says, let's look at how to practically measure 2D objects by estimating, measuring, recording, and comparing and ordering. The measuring instrument should be measuring spoons, measuring cups, and measuring jars. The units to be used is milliliter and liters. Problem solving definitely are going to be there, using capacity and volume within the content, and just using the liters and milliliters units within the problem. Okay, let's look at our worksheets. First one, this is assessment for learning. Keep that in mind. Measures, capacity, and volume. Have to have the name, the grade, circle, everything. It has to look like an actual worksheet. As we said before, state what is. That's important because that's Bloom's understanding. What is, okay, now it's application. This is application. This is where you are asking the child to estimate according to CAPS. This is estimating and measuring. Now, if a child just looks at the jar and it had no numbers, that's estimating. But since now it has numbers, now it's measuring because they know exactly what they're looking at. So they just have to read off of the picture, write the name down, that's measuring. Okay, what is the volume of the juice in the presented jar? Of course, yeah, volume. Capacity would be 1 meter, volume would be, the actual liquid. Describe the difference between volume and capacity, and that is evaluating. Oh no, it's in a way evaluating, but it also has another function in Bloom's. We'll look at it once again with the whole Bloom's taxonomy. This is is expecting the child to compare to put the letters, which is A, B, C, E, D, put them in order, arranging them from the least to the most big, the biggest one to the smallest one. Okay, did we do this according to CAPS, right? Yes, because we did, as we said before, it did encounter measuring, and with a measuring instrument, which is a measuring jar in this case, it did compare and order. It did use learning units, milliliter and liters. It did compare and ordering, which is what we did here. Recording, when you ask a child to measure, them looking at it and telling you it's this much milliliters, ma'am, that's measuring. Looking at the jar already has the answers, the numbers of the actual liquid. If they tell you, ma'am, this is the volume of the liquid, that's them measuring. But if they put it down on paper, now it's recording. So we've done measuring, recording, we've done comparing and ordering, asking them to to put the least to the least to the biggest. That's comparing and ordering, and we have used measuring instruments, in this case measuring jars. We've used the units. Now the second part of the worksheet, oh wait, let's finish up with blooms first. Let's look at remember state. We did apply that. What is? That's now asking a child to really understand. Do you understand the concepts enough to answer what it is? Like, what is capacity? Capacity is the total, it's the space available of the objects. In this case, the capacity is 1 liter because the jar has the ability to carry 1 liter of water, but the volume is what's actually inside. See? So volume is the liquid inside. Okay. So asking the child to describe the difference between volume and capacity. Now it forms under, I would say, analyzing. Definitely analyzing, because now you're comparing information. Also here, it's also analyzing. It's a bit of both for this question, because if you're describing, now you're showing that you can apply its understanding, but it's not quite apply. It's mostly analyzing, and this one is analyzing. Let's move on. The rest of the worksheets, which is the last part, exercise 2 and 3, it states quantity of a liquid to measure, whether is it 1 liter, 500 milliliter, 2 milliliter, 1 milliliter, 50 milliliter. Answer and complete the table. For an example, this is very important. You have to, for the child to get the what we're doing here, you need to add an example how you did it. So you're asking the child, fine, give me 650 of milk. How many of these units, of these numbers would I need? Okay, 1 500, 2 500. You get the point. So they need to do the same thing. Now it's a bit of problem solving, definitely problem solving within the contents of capacity and volume. See, so it's definitely this is the capacity, and it's asking the child how much volume to make this capacity full. You get me? So it's problem solving. And exercise 3 is to draw. That's still problem solving. Bonus question. In your third year, you'll learn something called differential curriculum, when if you add a bonus question, now you're giving the child a bit of, like you're giving them a bit of a separate curriculum than the rest, because most of the time it's the gifted kids who just go for the bonus question. So you're giving them something extra to keep busy with. Alright, so let's look at the memorandum. Capacity, I've explained this. Basically, I've explained everything. Yeah. Okay, is it going along with blooms? As I said before, this one is application. This is applying how volume and capacity, how you can fill up a capacity and how much volume you need to fill up that capacity. It's definitely applying, and bit of analyzing, because you need to think, it's a bit of both. It's applying and analyzing. Okay, fine, I'm gonna apply my my skills, computational skills, by adding, measurements together, but I need to look at units at the same time as a child. So you're applying your knowledge of units. right? Your knowledge of capacity. Wow, you're analyzing how much of this and how much of that I'm going to need. So it's both apply and analyze. Draw is definitely creating, because now you're asking the child to design themselves. So that's it for that page. This is just a memorandum. If you was like kind of shocked, why is it 2? Teachers can sometimes can make 1 mark, half a mark, basically. It's very important to have a tick. That's important. The drawing, yeah, you can just read the whole menu on your own. So it goes over, all explained already how it goes along with caps. So a bit of a recap: what to expect in second semester learning unit 1. As we said before, for these 4 areas, some of them I just looked at on the next learning unit, and we've looked at how these chapters cover the concepts area within CAPS using Luneta, and we looked at examples for formative assessment with answers. And really, thank you for your next video. If you still want to see more, it would be very much available a video that explains Luneta's chapter regarding each CAPS content area of learning units 2 of semester 2, and to analyze, demonstrate summative assessment questions with answers regarding learning unit 2 under the YouTube channel Miss Team Vega. The title will be Second Semester Summative Assessment Examples with Answers, Teaching for Deep Understanding. Thank you so much. Please subscribe, like, comment on what you would love me to cover next, and share with your friends. Thank you so much for joining me, student teachers. It was truly a ball. Bye.